Hi, this is Shubhra Chatterjee. Welcome to my Math News channel on YouTube, where I explore the use of mathematics in art. In the last video, I talked about tessellations, which is the covering of a surface using one or more geometric shapes called tiles, with no overlaps and no gaps. Today, I'm going to talk about tessellations in the work of the famous graphic artist, M.C. Escher, and delve deeper into the math behind two of his famous tessellations. M.C. Escher was a Dutch graphic artist, many of whose works were inspired by mathematics. In his works, he has explored many mathematical concepts like reflection, symmetry, hyperbolic geometry, and tessellations. He is known for his enigmatic works employing paradoxes and impossible perspectives that are at once fascinating and difficult to comprehend. Let us now look at a couple of his works. Drawing hands is typical of Escher's work, where he uses paradoxes. Here, two hands are seemingly drawing each other into existence. This is another of Escher's work called Waterfall, which shows another paradox where water falling to the base of a waterfall runs downstream only to reach the top of the waterfall. In 1922, Escher traveled to Granada, Spain, where he visited the Alhambra Palace and was captivated by the intricate geometric designs of the interlocking tiles, which were used to decorate the walls, ceilings, and floors. He was particularly fascinated by this tessellation of glazed tiles at the Alhambra Palace. This triggered Escher's interest in tessellations and was to become a major influence on his work. Now, let us look at one of Escher's tessellations. This is a woodcut by Escher from 1938, where Escher has used the interlocking shapes of bird and fish to tile the surface. This can be seen clearly along the center of the picture. At the top and bottom, the tiling gives way to clear images of birds or fish. In Escher's own words, in the horizontal center strip, there are birds and fish equivalent to each other. We associate flying with sky. And so, for each of the black birds, the sky in which it is flying is formed by the four white fish which encircle it. Similarly, swimming makes us think of water, and therefore the four black birds that surround a fish becomes the water in which it swims. Now, let us look at the evolution of Escher's famous tessellation series called the circle limit. Later in life, Escher developed a strong interest in the exploration of infinity. Having created multiple works that explore regular tilings of the plane, he was looking for a way to extend this to depict infinity, but was unable to find the right technique to do so. Escher had collaborated with multiple mathematicians, and one of them was Coxeter, who is considered one of the greatest geometers of the 20th century. In 1957, Dr. Coxeter published a paper called Crystal Symmetry and its Generalizations, which featured a hyperbolic tessellation, a tiling of a circle using triangles that reduce in size as they move from the center to the circumference, becoming infinitely small as they approach the circumference. Dr. Coxeter shared the paper with Escher, who was quickly able to recreate the tessellation with a pencil, ruler, and a pair of compasses. Escher got really excited at having found a way to depict infinity with regular tilings of the plane. This culminated in the creation of the circle limit series of tessellations. This is one from the series called Circle Limit 3, where he has used the technique shared by Dr. Coxeter to create a hyperbolic tessellation using figures of fish that diminish in size as they move away from the center, with this process repeating ad infinitum. I hope you enjoyed this video on MC Escher and his famous tessellations. In the next video, I will explore the world of mathematical sculptures, which are sculptures based on mathematical concepts. If you want to learn more about this topic, or in general just explore the use of math in different arts, please read my math art blogs on Medium.